Today we are going to build a 8-to-1 multiplexer. So we will start by selecting when you are going to build using Logisim. When you open the software, these are the interfaces. So when you look on the left top corner, you will see the tools you will need to do the multiplexer. So we start by selecting it. So to build the multiplexer, we are using the gate, even though we have the plexer on it. So we are building 8-to-1 multiplexer. We select the gates. We are going to use the AND gate and the OR gate and then the NOT gate to build the multiplexer. So we begin by selecting and putting them on the interface. So this is how you select it. You click on the AND gate, then you double click, you drag it and put it on the interface. So you can see it's big, so we have to shrink it to a minimum size. So we will narrow it and we get it to a minimum size. So that's how we select all the gates. And since it's 8-to-1 multiplexer, we are going to select 8 AND gate. As you can see, we've selected our 8 AND gate, but the input pins is 5, so we'll reduce it to 4. So you highlight everything. After you highlight everything, you click on it, and you come and change the number of pins to 4. And voila, we are done. So we go ahead and then we'll select the pins we use, and then that is the OR gate. So we'll go ahead and select the OR gate. We are done selecting all the tools we use to build the 8-to-1 multiplexer. So we are yet to connect the lines, and then we check with the LED whether our multiplexer is perfectly working. 3 inputs. We've connected those lines. We'll connect all to the multiple input using the truth table. So we are about to connect those lines too. We are beautifully done with the 8-to-1 multiplexer. So we have 3 selectors. As you can see, these are 3 selectors from S0 to S2, and then we have 8 input, which is D0 to D7. We've beautifully labeled all, and then we have 1 single output, which is Y. So lay the cables to connect all using the truth table. Using the truth table, our D0 will be 0, 0, 0. That's from the input to the AND gate. All the pins connected will be 0, 0. So we've connected those lines. And then the D1 will be 0, 0, 0, 1, because we are using the truth table. From the selectors of D2, S2 will be 0, and then S1 will be 1, and S0 will be 0. So we are going to connect that to the AND gate. D4 your S selector will be S2 selector will be 1, then the S1 will be 0, and S0 also be 0. So we connect those ones to the gate. Just keep in mind that you know the truth table and you follow it. You can see we are done with connecting the lines. So our D0, when we look from the selectors, we have S2, S1, S0. So our D0, the S selector is going to be 0, 0, 0, which will then connect it to our input. Then the D1, the selectors will be, the S2 is going to be 0, and then the S1 is going to be 0, and then the X0 is going to be 1, based on the truth table. And then when you come to the D2, you connect it to the pin, you look at the truth table, the S1 is going to be 0, the S2 is going to be 0, the S1 is going to be 1, then the S0 is going to be 0. You make sure you follow the truth table, do the same to all. After we are done, we'll then connect it to our OR gate and then connect it to the LED. Then we do multiple tests. So you can see our OR gate, we increase the number of pins to be 8 so that we can connect the AND gate to it, as you can see. So we'll be doing that connection now. As you can see, we are done connecting all the 8 inputs with the 3 selectors to both the AND gate and then the OR gate. So these are 8 to 1 multiplexer. So let's randomly check the input to see whether our LED will on. So let's look at, currently it's off. So let's look at our 1, 1, 1, and the LED still remain off. So let's look at 1, 0, 0. Now let's look at 0, 1, 0. So currently we are facing some challenge based on the fact that all our selectors input here are 0. So logically, when you make the whole thing 0, you see that we are facing this challenge. The LED doesn't turn on at all. So let's randomly change the numbers based on the truth table. So 0, you see, as you can see, once I put in the 0 based on the truth table, so we have 1, 0, 0, it will on, because based on the truth. So let's make it 1 as well, 0, 1, just randomly select it. So you can see our LED will on. So now let's try to change the selectors. 0, 0, 0, and the LED goes off. When we then make it 0, 1, 1, 0, 1, the LED ons. So you can see that our 8 to 1 multiplexer is working correctly. Thank you.